Hi and welcome. So a couple projects ago I made these 7075 aluminum T-handle chuck keys for my lathe, and I told you I'd come back and revisit the topic when I knew more about how well they were faring. Got good news and bad news for myself. Good news is the 7075 aluminum handles, even with these really long half-inch handles, plenty of torque and they don't bend. So they've been really great. The part I didn't think I'd have problems with, strangely enough, this is for my 4-jaw chuck, is the end that's made out of 303 stainless. Can you see the twist? So that material's too soft. So I'm going to have to make a new end piece. Also, as the chucks come out on my 4-jaw chuck, the chuck jaws come out, they're radiused because they decided to put the tightening nuts right under them, which makes sense because on this one there's a scroll in back that makes all the jaws moving at once on the 3-jaw, but the 4-jaw they're independent, and so it makes sense to be right underneath it. But they're right underneath it, so they've got a relief in the bottom of the jaw that's curve shaped to match the jaw. Well, it turns out this diameter is too big for that, so when you have the jaws out quite a ways, that becomes a problem and this runs into it. So my fix for this is to part this T-handle back a ways, create a new half-inch diameter hole in the middle, or maybe even a little smaller. Then I'm going to take this piece of 4140 heat-treated and tempered material that I demonstrated in a previous video, and I am going to make a new end piece for that, and this part will stick out. Now unfortunately it's going to make the handle heavier. I could just reduce the diameter of this 7075, but then I'd have to make a whole new piece. So we're going to see how this works, and it will make it a bit heavier than I like. I mean, the whole point of these was that they were ultra light, which is really nice. But let's see if this fixes my problem, because I'm not sure that this won't just break, that it'll be too brittle. It's got a Rockwell hardness of around 39. It is tempered, but it's tempered for maximum toughness, so we will see. So also trying to drill this is going to be interesting. I ordered some solid carbide drill bits, 1/8 inch. I'm not sure how well that's going to work because they're going to be really brittle, so have very little experience with it. So let's see what we learn. So the first step is I disassembled the T-handle, took the T part off, and now I've set up my parting tool and I'm going to part off just a little bit past the end of the stainless steel in here. You can see at this angle how badly bent it, how badly twisted it was. The metal was surprisingly soft. I mean, I was cranking on it really hard, and interestingly enough, the aluminum handles that I was way at the outside edges of when I was cranking on them, they didn't bend. This did, and it makes sense. This is, you know, those are huge torque arms on this very tiny torque arm down here for the center part, so there's a huge amount of twisting force, and so it's not their fault, but in any case, needs replacing. So live and learn, and maybe this won't work either, but we're going to try it. So first step, part off the bad end. Next I'm going to center drill and then drill one size under 1/2 inch and bore out the hole to 1/2 inch. You might be wondering why I chose to part this off rather than just pull the pins out and, you know, reuse the same hole, and that's because I could stand to lose some length anyways, because I have to extend the shaft with a smaller diameter section to clear the relief on the jaws of the 4-jaw chuck. So it needs to be a little bit shorter anyways. I don't mind long, but I don't want it crazy long. So anyways, that was my thinking there. So let's just get started after I put it in gear. Alright. I kind of left that in a much faster spot than I intended. Yeah, that sounds better. So we're drilling one size under 1/2 inch. You know, there isn't any reason I can't ream this hole, so I'll do that. Alright, ream for 1/2 inch. Alright, so let's measure this. Would figure that these telescoping gauges, that the size that I'm trying to end up with here is right between sizes on the telescoping gauge set, so I'm either all the way in or all the way out. So it looks like 1/2 inch and 4/10. Right on the money even. So I think we'll call that good. The reaming was nice. So next step is to make the other side that will mate with this, and I'm going to try and get it very tight, because if you have a lot of play, then this can move around a little bit and makes it more likely to break the pins. You want maximum support between the edges of the walls of this guy. So the next step, this is the 4140 right here, and hardened and tempered, and the first step is going to be to face this end here, which is really out of round. So we're going to face it, and then we're going to turn it down to 1/2 inch for 3/4 inch of length. And I'm going to try this a little bit slowly, because I'm not sure how this stuff's going to cut, and I forget since the last time I did these tests. So interrupted cut of hardened material. Boy, it looks like this was over 100 thousandths out of round. That's impressive. So we're going to take some longitudinal cuts. Let's go for 50 thousandths. And we're 3 thousandths of revolution feed rate right now. Is that right? Yes, we are. So 3.3 thousandths. So we're going to go for 50 thousandths depth of cut, and we'll try and do the first pass. See how this goes. Longitudinal. Go in about 250,000. So let's see how we do with 75,000 depth of cut. This is going to make some wicked swarf. Chip breaker's not engaging. Probably because my feed rate's not enough. notice as the service feet per minute rate goes down, the finish gets worse, so we might need higher RPM, which we will do. Ah yes, much improved the surface finish. It's interesting how that works. Let's see where we are diameter-wise. Yeah, the surface finish was greatly improved by speeding it up. So it's 6/10 over, 4/10 over, 4/10 over, 4.5 over. So there's a 1/2 taper. Alright, so let's get the final length here. Undercutting the back by a little bit there, by about 7 thousandths. I was going to do 10, but just so that it doesn't have any possibility of hanging up. Wants the piston out. Perfect fit. Really have to crank to get any slop at all. Nice. So this is going to be the first of a series of things that I'm not sure how they're going to react, call them tests. I'm going to center drill the end of this, which I'll cut off later, so that I can put support this with a live center when I take this down to final diameter. So I'm going to try and drill this with high-speed steel. Let's see how it reacts. Not bad. Makes me wonder if the hardness isn't what I had thought it was, or if the fact that high-speed steel can be reasonably hard, that's why it's not a problem. I'm not sure what the answer is, but hopefully when I'm done with this thing it will be strong enough. My current plan is I'm going to take this section here down to 3/4 of an inch in diameter, and then I'm going to taper ultimately down to the final diameter here for that center, for the diagonal cross section of the square part on this end. I'm going to leave this purposely long, so I'll turn it down to final diameter, leaving it long so I can trim off the end where I've recessed it or countersunk it for the live center. So that's what I'm thinking. So we're doing well at 75 thousandths depth of cut. I could increase the feed rate to try and gauge this chip breaker, but I think I'm going to leave it alone because I'm not sure. The stringy bits are a mess, but I'm not sure if I really want pieces of you know, material, little tiny chips flying all over the place of hardened material. So let's just try this. And the chip breaker's working right now. Go figure. Chips are nice and hot, they're turning blue. 75. I don't actually know the answer. So we're going to do 50,000 depth of cut so that I don't put so much lateral force. Let's try a little lube this time, see how that works. Alright, now the real 50,000. Other than making smoke, I don't think I'm really getting anything for the lube. Smoke's exciting. Alright, so let's bump the RPM up. Maybe we'll get a better surface finish because that's getting kind of grungy. So we need 40 thousandths off, so let's try 25 thousandths. Bump the speed up. I think I've chipped my insert. I think 75 thousandths depth of cut might be a bit excessive for this insert. I was sort of feeling a burr on the end, but my eyesight's not good enough to really tell, so I'm going to go grab a magnifying glass and see what I see. I think these no-name inserts can't hack it. Not that I'm sure a name brand insert would hack it either, because I don't have enough experience to say, but I'm a little disappointed. So I'm going to rotate the insert and come right back. So the answer was I did indeed chip the end of it. So I ground it down so I could tell that that's not a useful edge anymore, because it's really hard to tell without a magnifying glass, at least with my eyesight. I could feel it with my fingernail, and I should have trusted that first go around. But in any case, let's give the final pass here. We're looking for 16 thousandths. So let's give it a shot. Better finish already. I think these inserts, I think I ran across this before and I already have forgotten. I think if I go over 50 thousandths, excuse me, they have a problem. So we need to stay under 50 thousandths. Or I need to go to a bigger, heavier duty cutter. Now this diameter is not critical. The only use will be that's a much better finish, is that this final diameter here will allow me to put it in a collet if I need to work on it. So I'll have to see if that works out. I'm kind of curious actually. Alright, so now we got to take this end part here down to a final dimension. So we need it down to about 0.475. I have to change the angle of the cutter here because I cannot get in there. It'll give it more back relief anyways. Okie dokie, so let's reset my 0. Alright, so We're going from 0.75 to 475, 200 some thousand, so we'll do 50,000 passes. Hopefully this will not damage the cutter. So far so good. .597, so we have 125 roughly. Alright, let's take a measure and we'll come back and shoot for our final 475. 496, so 21. And I think we're going to bump the speed up a little bit more. It didn't seem fluid was helping, but that's when there was a chip in the cutter. So let's see, how about now? It's really looking pretty good. Good smoke generator. Okie doke. And we're there. Alright, so let's see if we can blend this in a little. I don't want the tip of that to cut in, because if the tip of this guy cuts in, it's going to create a spot where it's going to be more easily break. Kind of like, you know, when you score glass, and I can't get to this one. So, I'll do that next. Well, most of that material's coming off, so let's just get in here and get this guy. Alright. How did we do? Not bad. You know, I think I'm going to come in here and just see if I can clean this up. I like the look of it a little better if I can get this radius in there. I think that's better. Nice and smooth too. I like that transition better. Matter of fact, I can probably get this guy in over here and just use a radius to do that. Why not? Let's. In my view. Okay. Just need some final sanding on that, but that's pretty good. Let's see, do I have a ridge? Can't quite tell. No. Oh wow, that came filled with my fingernail. Alright, I'm liking that. So I just got to relieve that a bit. And to do that, I'll probably have to flip it around and mount this part in, which should be easy because it's 3/4 of an inch. So I'm not going to do that, and I'll do that. So I flip the part around so I can just chamfer this edge, and then I want to remove some material just to make that shiny, to get the mill scale. Actually, it's the mill scale I created by tempering, heat treating and tempering it. I did not get all the way through the mill scale. You can see the little indentations where it didn't quite remove it all, but I think I'm going to leave that because I really don't want to take the diameter down too much. So here's the finished part in the lathe. What I have left to do is I need to take this over to the mill and make this end square and trim off the excess where I countersunk it for the live center, and then drill and pin this into the main shaft of the T-handle. My use of multiple tapers on this guy has got me in a little bit of trouble, and that makes clamping very difficult because I got 1 inch diameter back here, 3/4 here, under 1/2 here, so I can't use a 5C collet to grip on this because the 1 inch will interfere. It's not long enough. So if I'd wanted to do this, I would have needed to do this a longer section of 3/4. Although I was using stock that I had, so that's why it ended up the size it was. But it's not ideal now. I've got to shorten this. Hopefully this won't be so much stick out. Hopefully this is rigid enough that I can take really light passes and end up removing all that material, because I'm going to try. So we're going to go there first, then we'll do the flats, and again I'll probably have to do really light passes because of all this stick out. I've got a jack here that if I have problems when I'm milling across the top that it's deflecting down, I'll put a jack under it and try and support it that way. We'll see. Let's give it a quick test and see how it works out. So try 800 RPM. This is a roughing end mill. Alright, so let's see, here's 25 thousandths. Let's just get a rough estimate. Maybe you can see this. So we're at 7/8 right now. So 7/8 has to go down to 6. So 875. So about 200 thousandths from here. Fortunately, it's rigid enough. It's working better than I expected. Alright, so we need to take off 45 thousandths aside, roughly, and besides the 45 thousandths aside, we need to go in about 6/10 here. So that's what we're going to do. this end's done. Now we just need to drill and pin. Alright, so I just countersunk this, drilled it, and now I'm going to ream it. My apologies for missing the video, but my battery died and I didn't realize it. So I missed that, but I will catch the next one when after I ream this. I'm going to put the pin in, then I'm going to rotate 90 and do it again, and I'll show you that part. Okay, so here's the second one. So the first one, the first hole and pin are at 0.25 in from the meeting point. Next one's going to be 0.5. So let's countersink it. Oh, I'm back here still. Alright, next we're going to drill. So for this one, we're going to slow it down. Perfect. Now we'll ream. Alright. And we are through. Alright, so here's the final assembly part 2. And just going to tap this guy in. I was going to use Loctite, but don't think that's going to be necessary. And seeing the luck I had with the last one, I might want to make it easier to remove. So just putting the 1/2 inch shaft back and lining the hole up with the set screw slot. So it definitely added some weight to it. Kind of made it nose heavy, which is fine. So it wants to drop down. So next time I use it, I'll get back to you and let you know how it goes. But this is part 2. So this is 4140, heat treated and tempered to about Rockwell 37. So I'm hoping it'll be strong enough. If it's not, it might just shear the end off, it might just snap. So time will tell. So thanks for watching. Hope you enjoyed me fixing my first go around with this. The long handles seem to be fine. They haven't bent at all. The 7075 aluminum seems to be really strong. If I had to do all over again and made a new shaft, I would probably just make it all the way with aluminum till the end. I think that would be better. But in any case, that's not how it worked out. So we're going to try this, and I'll get back to you as I discover more. Thanks for watching. Hope to see you again.